Hello, my CNC brother or sister. I'm Garrett with IDC Woodcraft, and I'm here with the Jenny bit maker, Cody Elkins.
Hello.
And he just got a brand new upgraded machine to make his Jenny bits, and it's the FX7. And so we are, or he is, you're dialing the machine in for the first time.
Yep.
And so what this video is a walkthrough as he's going through it, so you can understand the level of pulling a CNC bit, dialing it in, seeing how the machine works. We'll talk a little bit about the machine. You're going to watch it operate. So this is your upgrade. Why did you upgrade a machine, first of all, before we dive into this?
So part of the reason why I decided to go from the FX5 to the FX7 is just I have more increased capability and capacity. So the other machine can do, depending on the tool diameter size, like the 1/4 incher, hold like 200 tools about. But this one more than doubles it, gets it up to about 500. The other thing that's really important too is this machine has the ability to hold like 6 different wheel packs. And as you watch a video, we kind of talk about wheel packs and describe what that is. But it allows me to hold more grinding wheels at a time to continue grinding and doing automation on a larger scale. And then lastly, I got an upgraded spindle that has a built-in temperature control module, which is really important because when you're dealing with such tight tolerances, you have thermal expansion and contraction, and that will actually affect the grinding of your tools. So it gives me the ability to have more control over the process, to have more precision, quality, repeatability, and scalability.
And higher output.
Higher output.
Yeah. So this video is going to be kind of cool, interesting for you as a CNC creator running your CNC router. This will give you a good little insight into what it takes to actually bring that tool to you to do what it's supposed to do. And it'll give you insight into, like I said before, the depth of what it takes to get a CNC router dialed in.
Yeah.
So with that, let's get into this, where Cody is going to be starting to work on this machine. You ready to rock and roll?
Let's do it.
Let's do it. IDCwoodcraft.com. So you are manually putting a bit in.
Yep.
And this is a carbide blank. And you're setting the depth of the blank, the stick out.
Yes, the tool projection.
So the robot itself won't be used in this case.
It will when it does a wheel change.
Okay.
All right, I think we're good to go. First thing it's going to do is going to measure so the machine knows where that blank is at.
Okay, so it's got the tip probe there.
So now we're cutting the upcut portion of the bit.
So this is cutting 2 flutes or 3 flutes?
2 flute.
And how, you said it's going to make 2 passes?
Yeah, yep. So it kind of does like a roughing pass, and then it does almost like a finishing pass.
Okay, so explain how that works again.
So when you're grinding, you're removing a bunch of material, and in order to get the desired surface finish, I'm just about to do the robot.
So it ground that fast?
Yeah, that's the upcut section.
Okay, so it's a compression bit. So now it's grabbing the other wheel pack.
So now it's going to start cutting the down shear portion of the Jenny bit.
So this had to swing around in order to get into the orientation for the down shear.
Yes. And then what I do is, as I'm running it, I keep a close eye on the spindle load.
Okay, which is this
spindle load right there. So as you start removing a lot of material, your diamond wheels will start getting loaded up, similar to like when you're using a belt sander. And as that wheel starts getting loaded up with carbide, you'll actually see the spindle load, the torque starting to peak. And the machine can handle okay up to like 50% spindle load, but I'm kind of a baby and I get nervous, so I try to keep the spindle load as like low as possible.
Okay, so we see it slightly increasing. Is this on the second cut here?
Yes, I believe we're doing no, it's still the first pass. It's hard to see with that coolant on the door, but you can actually see the A-axis, that's the work holding that's holding your bit. Mm-hmm. So you can actually see it spinning as it's grinding. So now what I do, and again, this isn't necessary, but I'm just kind of weird like this, but I program it to where it goes in there and it'll actually measure the helix of both the upcut and the downcut portion, just to make sure that the alignment is proper when we go in there to start doing our OD.
Okay, so now that little yellow thing just kicked up. That's creating
Yeah, so that's called the pop-up steady rest. And what the pop-up steady rest is designed to do is as your tool comes in, it pushes up on the tool and it preloads it by a couple tenths. So that way when the grinding wheel comes down and you start grinding, that tool pressure that it's creating, it actually supports the tool and keeps it straight as you're grinding. So those who might be watching this, a wheel change is the same thing as like a tool change on your ATC.
okay.
So if you're running your Onefinity or whatever machine you have and you have the automatic tool changer, that's basically what the robot's doing. It's changing the wheel pack 1 to wheel pack 2, which is equivalent to switching from like a roughing bit to a finish bit on your automatic tool changer.
So the little kickstand is up the what do you call the yellow thing?
That's the pop-up steady rest.
Okay, so it's putting pressure on it. Is it on is there a spindle on bearings or is it just?
It's just a V-block.
Okay, because the bit itself is not turning very fast.
No.
It's just rotating slightly as it's moving back and forth.
So this is an O-flute, but you have the helix right here, right? And so as that grinding wheel's going in, it's gonna slowly spin as that wheel's going in there. So it's not spinning really fast at all. It's actually spinning at, I don't know, like 4 inches a minute or something like that as it's fluting.
And it's obviously made of a different material, or it's got a coating on it to give it the slipperiness as well.
I think it's just a steel, like a hardened steel, like V-block rest.
Okay.
So those will actually start to wear out.
Oh, do that.
Here, this is a 10 mic to 15 mic steady rest.
Mm-hmm.
You can see it's just a V inside there, but as you start using it, you'll get wear marks right here.
So you got wear marks on this one.
Yep. You can actually see where it's almost like it's just rubbing it away.
Right.
Because the carbide's harder than the steel.
When do you know when you need to change that?
If it starts affecting my grind, if it's not giving it enough support, or I'm getting really bad finish, or it's throwing it, if it's making the run out go bad, those are usually good signs to change them out. You can get other ones where instead of a V, it's actually a radius. So now it's actually using a laser to check the OD.
Okay.
If you look from that window down there, you can actually see the laser in action.
Oh yeah. Right. So what are we cutting now?
So now it's doing the in-face work. So now we're doing the gashing and the in-face. It's doing all that work right there.
Okay.
Matter of fact, I can just kind of blow this up. So it's cutting all this, the yellow or gold, the white.
So that's the actual end mill part of it.
Yep. Yeah, so it's cutting all that geometry. It's really funny. I've never actually counted how many grinds there are. But what we can do is I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 14 different grinds on the compression router.
So is it done now?
It's done. Let's open this bad boy. I don't want to pull it yet. We're gonna see what it measures on the OD.
Okay. This is not a finished bit.
Nope, we're just getting everything dialed in.
Right. So is that did 3 different grinds or 4 different grinds on this?
Oh no, this tool's done. It's done all.
Oh, it did them all.
It did them all.
Okay.
Yeah, the grind is complete.
Now it's got a measure.
We'll see where it's at. But I don't want to pull it out of the machine because if it's oversized, we can rerun it. If it's undersized, then we gotta.
So you're gonna mic it, or are you gonna use the machine to measure it?
I'm gonna see what the machine measured it at first. So it did. It measured big, which is good because now we can rerun it in mode regrind.
So after that adjustment, now you got it to size.
Yeah. Well, so the first tool, it was way undersized. It was like 20 thou undersized. So we moved the wheel, ran a second tool. Now we're oversized, but that's desired to be oversized so you can actually start moving that cup wheel in and get it dialed in exactly where you need it. So now what I'm going to do is I'm just going to take a look at the cutting edge, and I'm going to see how big of a land is on there, and then we got to kind of guess how far we got to come in until we can clean it up.
I think we need to come in really far.
So now we're looking at the cutting edge.
Yeah. So you see that gray line right there? So you have like the shiny and then the not so shiny.
Dark gray line?
Yeah, right where that cutting edge would be.
Yep.
That's actually the shank.
Okay, so it's...
So we're gonna bring that cup wheel in until that goes away and we actually get the OD we're looking for. We're just gonna regrind the OD and hopefully dial it in to where we need it. So when I'm in mode regrind, the machine remembers where the tool is at, so it knows how to index if we go to regrind it. And so I'm going to shut off all of the features except for the OD finish and the laser.
Each one of these is a grind.
Yes.
And so you're telling it, we're not going to do all these grinds except for whatever you agree to.
Yep. And then what it does is it'll actually remake the model in real time so I can see exactly what it's going to be grinding.
Okay.
So we're going to do the S1 diameter, the S2 diameter, and then we're going to check out the laser.
So for the compression, S1 is the upcut, and S2 is the down cut.
Yep. So now we'll go in here, we'll go to our cup wheel, and I'm going to move it 3/10 just to see what it looks like. So instead of plus 10 thou, we're going to go plus 9 thou and 7/10. So it's going to be 0.0097. And then we're going to regrind it. So now on this page, it shows me just the operations it's going to run. So we got the S1, the S2, and now the laser. And then we hit the party button. Now, if that didn't come in far enough, we have to move the wheel again and keep grinding it until we actually see it move.
Okay.
So we might have to do another 3/10 again.
So it's doing a measurement right now. What's the rocking back and forth?
So how this works is you have an ultra precision laser. It's actually called the Precision Ultra. And what it does is there's a laser beam in there. And so the tool will come up and it'll find top dead center of your tool, and then it'll oscillate. It'll go back and forth and it'll keep breaking that laser until it finds the very top dead center.
Okay.
And then it goes to the other side of the tool and does the same thing. And then once it takes those 2 points, it gives you a really, really accurate measurement. So it's like contactless measurements.
Okay.
You know?
So is it done now?
Yeah, so that's done. So now we can actually see what we measured. So it told me it measured at 249.7. So we're still big.
Okay.
So we're gonna do the same thing again, but we're gonna move that cup wheel in a little bit closer.
These are all the geometries of the grinding wheels that you have programmed into it.
Yeah, and every highlighted wheel shows which wheel is being used for that process. So
you're going to adjust.
Well, what I'm going to adjust. So it's kind of like a lathe, right? So if you're cutting something round on a lathe, if you move a thou on the outside, it's going to make your diameter 2 thou smaller.
Okay.
So it's the same concept with this. So I'm going to take this cup wheel and I'm going to move it out. I'm going to do 8 thou just to see where we're at. Well, no, let's do the full 10. So it's going to be 0.010.
So basically, at the moment, you're just setting one set of wheels right now. You still have other ones to do.
Yeah, I got to measure other features on the tool and then make offset adjustments as needed. So that's good. The core diameter, small also. So the final depth is 0.058. So I gotta do some math. 793. Let's just make that like 788.
So you're compensating now, you're adjusting the wheel diameter for the core depth of the bit
Yep.
to get it to where you want it to be.
So we're gonna go from 793 to 788. We'll move that 5 down. That's 0.005 of an inch. It's not very much.
And what you're doing right now is the core depth, which is down the center. There's a solid core, and then the grinding starts. So he's adjusting the core right now to the size that he's designed the Jenny bit to. Getting the machine dialed in, one step at a time. So what you're doing now is setting up for the bit. So you're gonna have to do this for each bit.
Every single time I set up a tool.
Okay.
Yep.
So how many Jenny bits are there right now?
There's like 20 something different tools that I make.
So out of that, then you got the 20 setups for each one. Once you get your rhythm in setting up a new tool or working to dial it in, how long, once you get your rhythm, how long does it take to dial it?
Well, it's like anything else. The more you do it, the more you get used to it, the more, like a lot of times I can go in there and I can see that line and I'll be like, oh, okay, well, I know if I move like 4/10, it's gonna be about a thou on the diameter. And so the more you do it, the better at guessing you get, especially when you're doing stuff like this. But I'd say on average, like the compression router might be 45 minutes to an hour doing a setup from scratch. Because the runtime takes a long time too. You know, I mean, this tool I think was, what was it, 13 minutes?
Okay.
That was just to run one. So if I have to run 4 tools to get it dialed in, you start adding up 14, 4 times. I mean, there's an
3
hour
hours,
right there.
yeah.
And that's just runtime. That's not doing any of the setup. So the more you do it, the faster you get for sure. But with this, everything's brand new, so it's taking more time. All the buttons are different. So on the FX5, I'm used to a certain icons and certain buttons. Now they're all different, so I feel like I'm just trying to figure everything out and be like, what the heck?
So you just cut your first tool on the machine here,
Yep.
right? And so you're checking out the diameters.
Yeah. So anytime you set up a machine, you always run out your first piece just to see where the machine's at. So this is the very first tool ever made on this machine here at Cadence Manufacturing. And it's bad. But the key thing is now I know where the machine's grinding. So Garrett and I, we're gonna go in there, we're gonna start tweaking the program and get it dialed in to within a thou or a half a thou from nominal. And so I'm just gonna verify the actual diameter. And see if my mics match what the laser says.
So what you're going to do is set your wheel, your grinding wheels, and you were set to 0.248 and you're getting 0.228.
Yeah, so 228.3 is what I measure on my mics.
30 thousandths under.
Yeah, so well, I want to shoot for 248, so 20 thou under. So because it's so far undersized, we're not going to change the diameter. We're actually going to move the cup wheel out by like 10 thou and then grind another tool and see where we're at.
Okay, and that's the wheel right there.
Yeah, so that's the cup wheel. So we're going to move this guy to make the OD bigger. But there's a couple other dimensions I want to check just to make sure.
And that's how you start with a brand new CNC machine that is cutting CNC router bits. So now you see what goes into getting a machine dialed in.
Yeah.
And Cody now has the finished ready bit to go. But because it's a brand new machine, this actually took you a while to start getting a feel for it with the new software layout, getting your packs dialed in properly.
So this is the very first tool that we ran on this machine. But in regards to getting everything set up and tested out, you know, Bob's been here with us since Monday, just trying to get everything set up, get everything hooked up, running the robotic arm, testing it, make sure it knows where it's at globally inside the machine so we don't crash anything. So there's been literally 3 straight days of just hooking up, running it, testing all the different features, just to get us to this point. But now that we got to the point where we can actually load our grinding wheels in there, touch everything off, and actually grind a physical tool, it's been hours, but it's fun and I absolutely love it. But in this tool specifically, some of the challenges that we had is going from the FX5 to the FX7. The FX5 software was an older software, so we're bringing in programs to the new software with a totally different machine that operates differently. So when we're bringing in those programs, a lot of it got jumbled up. So there were grinding wheels that were cutting in places that shouldn't be.
So basically, in a nutshell, number one, it's a brand new machine.
Brand new
Number
machine.
2, you got the learning curve of the software
and the machine,
and getting used to the machine.
Yeah.
And number 3, dialing in your tooling and getting the transfer program straightened out. So that's all the basic foundation, but from here now it starts to speed up in the dialing in of all the bits.
Yeah, so now I'm literally going to take one tool at a time, go through it with a fine-tooth comb, make sure that the programming looks good, make sure the wheels are where they're supposed to be, grind it, prove it out, save it as a save file on proven out program, and then just rinse and repeat. But this tool, we've been working on it for probably 6 hours straight, and it's one tool. It's not even completely dialed in yet. That's usually not typical. Usually it'll be like an hour setup, but now we're just getting everything dialed in and switched over, which is time consuming, but it's necessary. And it's gonna be better for everybody, I think, because it's.
Once you have a tool dialed in, so this is a compression bit that you finally got, how long does that take to run a full tool?
So depending on the tool and kind of depending on what I'm doing.
Let's just go with the compression.
Even with the compression router, on average, it's probably 13 minutes to make a complete tool.
Okay.
But that might take a little bit longer. I might be able to dial it in and make it faster. But it has to do with the wheels, it has to do with just getting that all dialed in. Because there's times where the grinding wheel, it'll wrap it over to the tool. Well, there's going to be a distance where it stops and then it slowly feeds in. It's grinding air for like 20 seconds. And so I'll optimize the tool path to shorten that gap up to make the tool faster. So as I do it more and as more that I kind of just run the tools, I'll optimize it and try to make it faster.
Tweak it more and more. So that's really.
But that goes into it.
Yeah. But it's kind of fun to be able to shoot a video with you and educate who's watching to get the back end of a CNC bit and understand what goes into it.
Right.
When you're putting that tool in your machine, now you're going, it's not just a bit. There's a lot of process thinking, machines, reworking the tool until you get it dialed in. And so that's.
Well, and the cool thing too is Garrett has spent a lot of time here, and we were looking at other tools, talking about tool design, and I had a chance to kind of explain to him my methodology and how I approach.
Super detailed. What I like about that is you're looking, because you're a user.
Yeah, I'm an end user of my own product.
Okay, I see this problem, and so you're solving that over what other toolmakers do. But you were going to say something. I interrupted.
Well, it's nice to know and see how the sausage is made in this case, because I'm taking the same principles that I'd learned in the aerospace and defense industry when I was doing manufacturing, and I'm incorporating that into the maker market, giving us better tooling that lasts longer. It's just overall it's awesome.
Yeah.
And there's a lot of detail that goes into it. And all of it is literally designed around to make our lives easier and better when we're running our Shapeokos, Onefinities, the SandSmart, like all these different hobby grade CNC machines. Now they're designed specifically for that application, which just makes our lives better, I think.
Yep. So this is where people ask me, what's the difference between IDC bits and the Jenny bits? And I like to explain it like this. You'll go to Amazon, you'll see 3 V-bits for $10. Those are so super cheap, they really bad cuts. Those are like the Pintos of CNC bits, right? Then you have like the Chevy, Malibu, and then you're getting up to Cadillac, and that's where I like to have IDC Woodcraft at with a broad tool base. These bits are like Ferrari, right? So you're getting like high performance CNC bits, and that's why IDC Woodcraft carries them, because I want to have that level of CNC bit, and it's just a good partnership. We've spent a lot of years talking to each other, watching each other grow, and it was just a good, for lack of a better word, marriage of businesses.
Yeah.
And so IDC Woodcraft carries the Jenny bit line, so I will link that down below in the description. And that's it. If you found this kind of interesting, you've got some questions about how CNC bits are made, put comments down below, give this video a thumbs up, and remember, at IDC Woodcraft, we carry the Jenny bits.
Yes, sir.
Cody and I partnered up. It was a perfect partnership.
I agree.
And basically, we can't keep your bits in stock. We're constantly ordering from
That's awesome.
Yeah.
I'll wear that as a badge of honor any day.
Yeah.
So
I really like the partnership. Anyway, there you go.
Yeah.
Cody, thanks
Enjoy.
for
Thank
taking
you.
the time. IDCwoodcraft.com